Hello, my name is Ali. When I say scenario or scenario modeling, I mean situations where we create a big event based simulation or a complex optimization process and we want to run it many times under different settings. What if the conditions are so and so? And then what if the conditions are so and so? And then we compare under those different conditions. Usually these scenarios could be run in parallel because they are definitely independent, and each calculation of every scenario takes a very, very long time. So parallelization can save us a lot of time, although we make the computer work hard for us. Python, I personally believe that when one defines components and works with Azure machine learning pipelines, that the YAML and the CLI is cleaner, much easier to understand, and naturally, it's more friendly to Gitting, that's DevOps and so forth. Um, because I had to set some of my settings, you'll get to it in a second. It does feel as if there's still work for Microsoft to do to stabilize this a little bit more. The Python bit feels much more efficient in it, or correct in its working. The CLI is a little bit more clunky, although what I said before in the previous point, I did get it to work, and I'll show you that one. But I think that Microsoft is still developing and changing because terminology is changing compared to what is in the documentation and so forth. So it still feels like kind of preview or just when the GA. And there's really good examples. Let me show you some of these examples and tutorials where you can find them. Um, so when you go to the Azure Machine Learning in the samples, obviously you've got, and I always focus on version 2 now for the SDK 2. The tutorials is natural. You'll find good examples for you working with pipelines and components under this E2E DS experience. However, what is hiding is under the SDK Python jobs. There's three examples here of different ways of parallelizing, and I've definitely uh, learned from these different examples. Um, the README here will tell you the contents of each one of the examples. They're kind of similar but different, so it's worthwhile going for all three. And the way I approach it, the way these approach it is more from the Python side, although there's occasionally YAMLs and so forth. I will do it totally CLI and YAML. So, what is being parallelized? If you're just working with big data and you want to parallelize the processing of the big data, Spark by Spark, not scope of the discussion of today. If you have a function and you want to call it for many, many elements of a particular list, then you just use the Python multiprocessing. Or it does multi-threading. So it's within a particular core, within a particular compute. If you've got independent models, so something like what I have here in the drawing on the right, then if you've got two modules that are totally different, you just use your regular uh, Azure machine learning pipeline. So I read my data, I explore here, logistic regression, I apply here, random forest, and then I compare them here. But if you have a situation where you've got loads of files and you want to apply to each file the same process, let's say the example they give here is loads of images and you want to process each image before you do something with them, or you've got a data set and within the data set you've got different geographical areas and you want to run analysis per geographical area. So it's the same analysis. That's where the parallel component that is provided within the Azure machine learning pipelines and components comes to its own. Really advanced parallelization comes when you use the Kubernetes or the Azure Kubernetes services. You containerize and you run many containers in parallel. And I really love working with Dask. I think it's a beautiful concept. However, I want to focus today on the Azure machine learning pipelines. It's within the tool that everybody's using when you use Azure machine learning, right? So it's just there and it's available for you. You don't need to go out and from the paradigm of Azure machine learning into containerization. It does it all for you. How does a population of birds develop under different conditions? Perfect scenario modeling. I'll show you how I build a component for that. Then there's one way of running it, which is, oh, I've got a component. I just run it many times. And because a component is practically a container, then you can run it as many times as you like. And I'll show you how to do that. It's not very elegant. And you need to work a little bit harder to wrap it into something automatic if you really want. So of course, why not use the AML parallel component? And that's where I'll try to end up soon. It does look very complicated the first time you try it out. But once somebody shows it to you, it makes a lot of sense. And the more you do it, it just becomes I don't want to do it in any other way. So the first thing I said I will do was the BirdModel itself. So I have just created a notebook where I tried it out. So the BirdModel itself is a package called birdie.py. I set up here the scenario with some variables. And what I've decided for this session is that I just change this particular setting. I don't start messing about with other things. There's no point. You get it. You run the simulation itself. You get a KPI. You get some graphs. You can do, if you want, a little bit more sophisticated intervals, more KPIs. Yeah, no problem. So how do I containerize it? So the first thing I did is I have two folders here under the BirdModel. One of them is called components, and the other one is pipelines. So let's start with a component which is called one BirdModel. I've got a definition of a conda environment that I will be using. Just really this one in a conda environment. And a Python program and a YAML program that wraps the Python program. So the Python program itself takes into as input, because I'm going to run it for a Python command, then it will have the arguments. So I get the arguments using the argparse. I take two parameters in, one which will be really the input, which was the rate of spread, and I'll write it to some output folder. You see here there's an ML flow job that I will use in this particular component, but not in the others, just to show you it a little bit. And this is the program I showed you beforehand in the notebook. So set up the scenario, get the rate of spread as the input, calculate the simulation, get the KPI, write that KPI for the ML flow into the log. and do the plot. And in this case, I'm writing the plot into a file rather than just displaying it, and finish it off. The YAML tells me that I want to use, I've got this as an input, this as an output. I'm using a particular environment, and you can, instead of going to a Azure machine learning environment, I just say, hey, look, the image will be this image for my container, and this is where you pick up the definition of the Conda environment. And then please run this command. Now, really, the command that I need is this one over here. Just run one BirdModel, and I just want to show that you can run several commands before and after, and this would be good because if you what I'm doing here, and you'll see in a second when I run the pipeline, I'm writing to a particular Azure machine learning data store. So if I run it several times, all the files will go into the same place. So maybe I want to do a cleaning of that particular folder. So I just do Unix RM. I can clean before I run this, so I don't need to bother to do it in Python. So the one BirdModel pipeline will look like this. Here I am defining the input. Here I'm pointing at a particular data store within Python, and I called it one BirdModel pipeline. And I'm running serverless. Why not? The default data store is this. And I run just one component here with the inputs and outputs defined as the inputs and outputs of the pipeline. There was one important thing that I learned whilst doing this. The regular pipelines within Azure Machine Learning have this set up as false rerun true by default. But later on, the parallelized component, for some reason at the moment, comes as false. That means that if you run it several times, you still get the artifacts from the previous runs. And if it sees it there, then sometimes, oh, I've got it, I don't need to run. So I'm forcing it to rerun each time. Worthwhile. Okay, so how do I run this? First of all, I need to log in to the AZ service, because I don't need for this particular instance. But when I get to the parallelization, you do need to set this flag to true, clearly saying that this is still not in the full GA. And then I run this command, this particular command, and I run it from the terminal window. You can see here I've already run it. No, I didn't. I just logged in. So let me just now run it. And once it's running, it can take a few minutes. Let me show you here how it looks. If you go to pipelines, you can see all the previous runs that I've made. In the jobs, you can see those runs, previous runs. So for instance, the first run I did one BirdModel beforehand. So this one, you can see it here. And if you want to see the outputs, you can see the outputs over here. There's one run there. And actually, if you go to the jobs, here you go. So if I see that there's one bird model running, there's the previous ones that ran beforehand, and I can add here in my columns variables that I've exposed through either through the parameters of the job or through the ML flow, and I'll just move them over there. And here you go. You'll be able to compare the different runs. I once ran it with 75, then with 50, 50, and this is the total number of infected. Of course, you don't have one here because it's still running. So if I go in here, you can see it's still running. And because I've sent it to my data store, if I go to the data store, to the BirdModel 01, you can see here one BirdModel pipeline sits over here, and here the different data sets. Of course, I ran more in preparation, so you'll see how I do them in a second. So actually, why not? How do I get to run several runs with different parameters? So what I've done is something really, really basic and very primitive. I've taken this particular YAML and I've duplicated several times, and each time I've written a different value over here and run it. So of course you can do it in a more sophisticated way, but this is the simplest way. I'll set my inputs and outputs in the file and just run it, and I have different pipelines for different scenarios, and I just ensure that when I write the outputs in the files, I'll show you again here in the one bird model, you'll see that actually the name of the file, let's say the image that I'm generating here, includes the rate of spread in the file name itself. If you want to see it, if I go back to the pipelines, and let's take one that has already run. Let's take this one, for instance. And I go to the output logs, show outputs. You can see the graph here is the first file that I get, and then you can see also the infected will be as other graphs. So it's time to look at the parallel component. Now, as I said, I prefer working with the YAML, so I'll walk you through the definition of the YAML file for a pipeline that includes a parallel component. However, things that were working yesterday are not working today. One small thing, parameters are not passing over. It seems that the Python way of defining the pipeline is more stable. That works. Something went wrong with, and I think I know it sounds like an excuse. I don't think it's a backend of Microsoft that's gone. That they're still developing this capability for the AZ run of the pipeline with the parallel compute. So let me just show you the definitions. First of all, the components. No matter if you're running it, I'll show you first of all how it looks. So I've got here two runs. One of them, this one was run with the Python notebook, and this was run with well, it's running now, right? with the YAML. I think I fixed it. So when you go here, what you see is two components. No input, because I generate the scenarios within this component. Naturally, you could have a JSON file or some other file defining the different scenarios. You take it in, you break it up. But I just defined a list here with the values, and then I broke it up into separate partitions that drive the parallel component over here. I've defined the YAML pipeline a little bit differently. It will look slightly differently here. So you've got the two components. However, I'm linking them here to well, you have to in YAML you'll have to define this as an output for the pipeline, and then here the result of this I'm writing it to blob storage, and that's the bit that actually I needed to fiddle around a little bit with to data Azure machine learning data store. Sorry, to be correct. So how do the components look like? And there's a special structure for this particular component. Let's start with the easy bit. So my scenario prep component is a simple job where I define a list of values. Yes, this could have been also an input parameter to this particular component, and I could have defined it in the pipeline itself, correct? And then I just run for the values and I create a CSV under different folders. So originally, when I had all the CSVs or CSV per scenario in the same folder, the parallelization job picked them all up on the same node. The moment I put them under folders, then like mimicking an M table, because that's the way the M table will be working, then immediately this was spread out on the server, the three nodes that I provisioned for this particular job. So this is no more, no less. This is just the scenario prep. So I ended up with many files. So if I go here, sorry, not this one, this one. If I go here and you look at the outputs and the data, you'll see I've got, I think in this one I'm running it with 3 scenarios, right? So you see I've got a file per scenario and it's got a different name, 01, 02, 03. And it's just a CSV with one value in it. By the way, just to show you if you're interested, when you go here, if you click here, this will give you access to the blob storage itself. The blob storage itself, you can see the different folders, and under each folder I've got one table, and the table has only one value at the moment defining the scenario, which is this. But of course, you can immediately see how this could be scoped out. Now, when I go and look at the scenario, this was the scenario prep. If I look here at this dot, the definition of the job, you see the structure has to have an init section that's run once, and the run section that's run for every value in the batch. Now the batch input is defined. I'll show you in the YAML. I'll explain it in a second, but just you'll see here, the batch is defined here with this parameter input data, and the task itself is like a different component. This definition is here. So you can see I've said this is the code. This is where you find the environment, and this is the arguments that you pick up. So it looks a little bit different to a regular component definition, which is over here for the scenario prep. So this is the scenario prep job. This is the parallel step. So if I go back to the parallel models, so in the init, really what we do is just get the arguments. And I don't need to take in the input parameter because it directly is directed into the mini batch. The input for the run job. I just take the output folder, and this is kind of what is broken at the moment in the YAML version. So when I run it in the notebook version, this works nicely. Here it's just not picked up. So I also defined a default, because really this comes in as empty. So I take this and I use that, and that's it. So in the run bit over here, then the batch could be more than one file or value. So you need to run through all the value within the batch and do something with it. So here we are doing it. This is an opportunity to parallelize again. Yes, you can do a multi-threading job if you like here. But what I do is I read my config file that's in the list of the mini batch, and I run the simulation like I ran the simulation beforehand. And in this case, I also am collecting a list of all the results in a nice formatted way, so I can have a file summarizing it all. And then I'm just creating CSV files and a graph with a nice title to it, that I know exactly what the graph it is. And that's it. And at the end of the loop, I also write the results here. And a few other things to the message. So how does it look when I look in the... Let's go to the job where I run more scenarios in. Which would be this one. First of all, you can see a little bit information about the job itself. And this is quite nice, because this is where you have a meaning for this particular tab. It says, okay, here you can get to the child jobs over from here. And there's high-level outputs and logs that might be useful for some debugging. Let's go directly to this one here, because the output here is a little bit more different than regular components. So in a regular component, let's go to this component. If I want to look at the outputs and the user logs, here's what this is, a print statement that I made. No problem. If I go here, you still have the user logs, but this is there's a log per node. So you see, I've got here 3 nodes, but this is really meaningless. The better informative ones are under logs. Under user, you've got the output and the errors for each one of the nodes. So for in this case, it just ran on node 0. You can see there were 2 batches on node 0. I had runs where this was over 3 nodes. So this looks like warnings here. And if I look here, these will be my print statements. You can see that this is the folder that it's writing to. The batch, there's a certain batch, and it wrote something, and then here this is scenario 05, this is the value, this is the total number of infected, this is the file that it's created, and a little bit of a timestamp, and here's the next one, and here's the next one, and it's fine. That's nice. I would point out that there's for debugging, these folders there's a lot of very, very useful output in these nodes. And when it works, these are just informative statistics about the performance. When every job in the mini batch started, how long it took, and all sort of bits of information you might be interested in. And same goes for metrics. Yeah. In the overview tab, first of all, in the settings tab, you can see what was the where does the output get written to, and a little bit of information here. And in the overview, there was a nice thing I noticed. I never managed to get going, but you should be able to get the YAML definition. For me, each time I press on this button, it just works and works and works and freezes. But I was really curious to see, this is a job that I defined using Python, how would the YAML look like from their point of view? So instead of that, I just spent time trying to figure out how to get it to work. So let me just show you one or two things in the YAML itself that I've learned. So if you go here, so the notebook looks like this, and I must admit I less like the way it looks, but maybe because Python, because Microsoft have chosen to do most of their um, uh, tutorials with Python, I suppose most people prefer this. Um, so the Python bit is connect to the environment. This is the cluster that I'm going to use. Load the component. So this is the preparation component. This is the definition of the parallel component. And the inputs and outputs defined here. And this is quite similar to the YAML, and this bit of the task is a run function actually. This works quite well. Note, and I noticed this, they put a space after the um, definition of the inputs. I think that's quite critical. So when I went into to create the YAML, you'll see it's very, very similar. One issue is that when I run the YAMLs, it needs me to change the name each time. There's a bug there that I need to probably report. Outputs. This job doesn't. This pipeline doesn't have inputs. Here's the different settings, and you can. And the trick is here that in the scenario prep, it's just a regular component, like regular definition of components, so that's not an issue. But when I come to the parallel step job, when you define the inputs, so that's no problem, just point at the output for the previous job. And then you see I call this job output folder. I refer to it over here in the program arguments. And I can see, just to show you the end results, if we go, over here. If we go to, just make sure that I'm clicked on this. I've got here for every scenario I've run, I've got a file. So this results is just a summary of the last one, but you've got scenario 1, here's the image for that. Scenario 1, the number of affected, here's the file. Scenario 1 results. Here you are, you can actually do like this, and you can get the columns correct. And then scenario 2, and scenario 3, and scenario 4, and so forth. And because it's written to a data store, there's no issue now doing another step, collecting all that and summarizing and creating a graph which summarizes everything, for instance. I think this is a very useful tool. I'm hoping that Microsoft will resolve the technical issues around the JSON definition of the YAML definition of the pipeline, because I do prefer to work with YAMLs. Also, something that to be investigated, and I suppose this could happen later on because I didn't manage to get it. You see, when you define a step, you say, oh, all the definition of the components sitting here in the YAML. So I would prefer when I define the parallel step to say all these things, inputs and outputs, fine, but then the rest, all of that, should live in a YAML component somewhere within the folder, rather within the pipeline definition. I did not manage to get that going in YAML. As you saw with the Python, you just have a different job that does a different cell in the notebook that does that, define the function. Thank you very much for listening. And I'm putting a link, obviously, to the GitHub repository with the code. I'll be more than happy to get comments, suggestions from people who have tried this. And if you've got insights, I will please do help out the rest of the community by just making notes on it in the discussion at the bottom. Thank you very much for listening.